In this video, we're going to solve this partial differential equation given the initial conditions. So we're going to take advantage of a theorem that says that u of x of t is a sum from n equals 1 to infinity of b sub n times e to negative n squared times pi squared times kt over l squared times sine of npx over l, where b sub n is equal to 2 over l times the integral 0 to l f of x times sine of n pi x over l. Now, these are the initial conditions, and notice that this is my f of x here. This is my capital L. So first, in order to find k, I'm going to divide both sides by 5, because this thing right here is going to be my k. And because at time 0 it's 0, a sub 0 is going to be 0. Because usually you have a sub 0 over 2 plus, but the theorem says because the initial and the final here, because this is over the interval 0 to 10, since at both endpoints it's 0, this thing is just going to be 0, so the formula doesn't include it. Now, I'm just going to plug in here L equals 10. So on the bottom I have 10 squared, which is 100. K is 1/5. 1/5 over 100 is just 1 over 500. So that's why I have the 500 here. L is 10. And now we just need to solve for b sub n. So for b sub n, we do 2 over L. L is 10. Integral 0 to 10. We said from the previous slide, f of x was 4x. And now we just need to integrate this thing. Notice that in order to integrate this, you have to use integration by parts twice. And unfortunately, it's quite a bit of work, so I just saved some time here. Notice that cosine of pi n alternates between -1, 1, etc. So that's why I have a -1 to the n power here. Sine of pi n is always 0. So like sine of pi, sine of 2 pi, sine of negative pi, etc. is always 0. So I just got rid of this thing. So this simplifies to this, and then pi and n, I can cancel the exponents there. So I have -400 times the quantity -1 to the n over pi n. And this is when n is odd. When n is even, it's 0. Okay, so the b sub n is equal to -400 times -1 to the n over pi n if n is odd, and 0 if n is even. So my final answer is actually over here, with the condition that b sub n is equal to this.